Hello everyone, this is Abdul, and today we are going to discuss on content hugging and content compression resistance priorities in iOS auto layouts. So welcome to the comprehensive tutorial on the content hugging and content compression resistance priority. If you are a budding iOS developer or even a seasoned pro looking to enhance your auto layout skills, you have come to the right place. In this tutorial, we will go deep into the essential concepts which will help you to create a user interface which will adapt to the different content sizes and device orientations. So before moving on to tutorial, let's first see what are content compression and content hugging priorities. So basically, content compression and content hugging priorities in the world of iOS development, they are used to create responsive and adaptable user interface. Content hugging determines how much a view want to resist growing larger than its intrinsic content size. It's like telling a label, I want you to stay small unless you absolutely have to grow. On the other hand, content compression resistance priority defines how much a view resists to shrinking smaller than its intrinsic content size. Like we can say, instead of Apple, we can also say that we have a button and don't make button tiny, keep it readable. Like if there are views on the left and right hand side of a button and they want it to compress. So in order to make the button readable, we are going to change its content compression resistance priority. So in this tutorial, we'll demystify these priorities and we will show how to apply them to user interface element, providing practical example that will make auto layout a breeze. By the end of this tutorial, you will be equipped with the knowledge and skill to create iOS interface that will adapt to the different content and device sizes. So let's dive in and start mastering content hugging and compression resistance priority. So first of all, we'll look how content compression resistance priority work. In order to look into how it works, let's add two texts side by side. So I'm going to add horizontal stack view to arrange two views horizontally, and I'm going to center this horizontal stack view in the center of the screen by setting center horizontally in safe area and center vertically in safe area. After setting its position, I'm going to add a label and I'm going to give the stack view a leading constraint of 20. Next, I'm going to add another label and we can assign the stack view distribution property from this attribute inspector to fill proportionally. Now we can see that labels are being filled horizontally and in a proportion. So let's change this label to title name and let's add our name here, Abdul came on. For short names, for names with a smaller length, we can see that it's being displayed correctly. But what if I add some more cons to it? So let's add now we can see that name is being compressed. In order to avoid this compression, we can set a compression resistance priority. So the labels or views are arranged horizontally, so I'm going to change the content compression resistance priority of a name to 1000. This way it will not shrink or it will not get compressed from the pressure from the horizontal views, from the leading and trailing. So now we can see that name is not being compressed and it's being displayed correctly. So this is how content compression resistance priority work. Right now we have increased content compression resistance priority horizontally, but if the views were arranged in vertical order and the views, any view was being compressed and we don't want that view to be compressed, we can increase its content compression resistance priority vertically. So next we are going to look at content hugging priority. So in order to look how it works, let's add two labels side by side again, but this time we are not going to add in a stack view. We are going to set center vertical and we'll give leading to it. So let's add a leading of 20. Next, I'm going to add one more label. So I'm going to copy and paste, and I'm going to give it trailing, and I'm going to center vertically. And again, I'm going to give trailing of 20. Now let's add space between them. So I'm going to give horizontal spacing, and let's give horizontal spacing of 20. Now it's showing an error already, but let's first write name here, and let's add. So here we can see that we have already filled name, and we have also give a title name, but it's not expanding. So let's set its horizontal content hugging priority to 252 and see what's going to happen. So what we did was we just increased name content hugging priority horizontally, and how it worked was that after increasing, any view or label with higher hugging priority will stick to its intrinsic content size. So we have a label here, and inside this label its intrinsic content size was declared by spelling NAME name. After setting its hugging priority to 252, what it did was it set its width to its intrinsic content size. As we can see, after increasing content hugging priority to 252, it automatically set its width to intrinsic content size, and our app gets arranged in the order we wanted. So in the conclusion, we can say that hugging priority is that content does not want to grow, and compression resistance is that content does not want to shrink. I have also added an article in the description below. Do check it out and feel free to share the suggestions. Do subscribe and stay tuned for more.